Class, what's up? Welcome back to our next video. We're still 6.1. We are focusing now on word problems, basically. Okay? Word problems. What we need you guys to understand before we really get started with this is that we can talk about speed in a couple of different ways. The way we normally talk about it is linear speed, right? Distance over time. Miles per hour. You might see kilometers per hour, or kph. Or you might see meters per second. So these are the three types of things we're looking for, and this is what we know, right? Like you're driving a car, you're going some distance in some time. Now, there's also angular speed, and angular speed occurs when something is spinning. Okay, so you need to have something spinning in a circle. But now we're talking not about a distance that something travels in some amount of time. We're talking about the angle an object travels or spins. Okay, so we use something like degrees per second, radians per minute. Not too challenging, but we will get into that in a little bit. Now, a lot of these word problems are going to require you, and you'll see RPM a lot. We remember, hopefully, a revolution is just one full spin, right? Right? You start here, and you go from the start. Whoa, that was bad. One time around to the finish. One rotation. That is a revolution. And RPM is a revolution, or revolutions per minute. Revolutions per minute. Alright, so whenever you see RPM, I want you to think revolutions per minute. Alright, now before we really get into any of these problems, we need to go over just a few more things of like back notes. We know that a revolution has 360 degrees in it. We've talked about that already this chapter. We've also talked about, if we're not talking about degrees, we're talking about radians. Do we remember how many radians there are in one revolution? Yeah, 2 pi. 2 pi, and I'm going to put rads here just so we remember. And again, I'm putting rads. Another reason I'm putting rads here is because we're going to be trying to cancel out units, so it'll be helpful to see radians. Alright, for length, we just need to remember, what are we talking about? We're talking about one revolution. Let's go back to this picture. One revolution is one full time around. So what's this actually called? What is one revolution actually called? Guys, that's just circumference. Okay, that's just circumference. So we're going to say that one revolution, if we're talking about length, is 2 pi r. And I'm just going to put units there because I don't know what the units are going to be yet. Alright? So be on the lookout here. Be on the lookout here. These are boxed for a reason, right? This is angles. If we're trying to talk about angular speed, like degrees per second, radians per minute, well then you're going to have to use degrees or radians. If we're talking about length, right? If we're trying to get linear speed, then you're going to need to remember that a revolution is actually 2 pi r units. Alright? Okay. We'll get to that in a little bit. Last little bit of notes before we start working on some of these word problems. This idea here, I don't want you to get hung up on it. I just want you to remember and understand a statute mile is just a land mile. It's a normal. I shouldn't say normal. It's what we know as a mile, right? How many miles between here and Chicago or something like that. All right. A nautical mile is more like a water mile or a mile in the water. And the only thing I need you to be on the lookout here is that sometimes we'll call that N miles. Okay. What's really nice is with land miles, we a lot of the times talk about miles per hour. Just be on the lookout that when we're talking about nautical miles per hour, we're talking about knots. And that's just something that you need to be on the lookout for problems in the book. All right? Okay. Last thing. We talked a little bit about this yesterday in one of the word problems. We remember that in math, we love standard position. We love standard position. And we know that standard position, if I change colors here, standard position would mean I would have my initial, and then I would go positive to something like this, right? And that would be my angle, or theta, I'll put just for right now, theta. Well, in navigation it's a little different, and if you remember that word yesterday, we were talking about bearing. Alright, so with bearings, we need to remember that a lot of the times we like to talk about due north, due north. So instead of starting at the positive x-axis, we start at the positive y-axis, and now our theta goes something like that. Okay, so this is just something to keep in mind for our word problems. Alright, I think that is enough of background information. If you need to go back and think about any of this again, please make sure you rewatch so you're confident and comfortable with these ideas. But now we're going to get into these word problems, okay? We're going to get into these word problems, and if you can read, which I hope we all can, it says right in this box that we're going to be doing unit conversion tables. Some of you guys might have done this in chemistry or other science classes. I think this is the easiest way to do these problems without having to memorize a ton of different formulas, okay? So, as we read this, we see a child is spinning a rock at the end of a 2-foot rope at the rate of 180 revolutions per minute. Find the linear speed of the rock. Okay, so let's look at this. First things first, I would say let's draw a little picture here. We know we have a circle, right? We know there's a rock at the end of a rope, and we know that the rope was 2 feet long, so we know the radius is 2. All right? And let me actually put feet here as well. I think that'll be good. 2 feet. All right. Well, let's see what else we can go back into the word problem and figure out. We know 180 revolutions per minute, and we also know that we're looking for linear speed, okay, or miles per hour. So what I want you to think about, guys, and understand, is we are giving you something in revolutions per minute, and we have to do work to change this into miles per hour. All right, we have to do a bunch of converting. And so the easiest way to do this, some of you guys might make a huge bar, which is okay. I'm completely okay with that. I'm going to make just a giant bar, and that bar is actually a division bar. And what I'm going to do is I am going to put what I'm starting with. I know that I have 180 revolutions occurring in 1 minute. Now let's take a look at this. We know that revolutions have to turn into miles, minutes have to turn into hours. All right? I would say the easiest, and so I'd probably start with this every time. I know that I have to get minutes into hours, right? So I'm going to make another bar here. And I'm going to understand that if I want, actually let me rephrase this. If I have minutes in the denominator, where do I have to put the unit minutes to cancel out minutes? I have to put minutes in the numerator. And I know that there is a conversion between minutes to hours. There are 60 minutes in 1 hour. So this is great because now what's going on? I can cancel minutes, and I have the hours in the denominator that I need at the end of my problem. Okay, so I'm done with my time. Now I need to worry about revolutions to miles. So let's think about this. Let's think about this. I know that I can do what? Let's see here. I know that I can put revolutions because I know that I'm trying to cancel out revolutions. And now in the numerator, let's think about this. Am I trying to get to a length or to an angle? Miles is a length, okay? So that is what I was kind of talking about here. We need to use 2 pi r, not 360 degrees or 2 pi radians. We're trying to convert to length, so we need to use 2 pi r. So let's see here. I'm going to have 2 pi, and then let's see here. We knew that the radius was 2 feet, so I'm going to put a 2 in there, and then I'm going to have feet. All right, and that's all in 1 revolution. This is nice again. Why? Because now I can cancel out revolutions. I'm getting there. I'm close. I now have feet per hour. What's the problem? I don't want feet per hour. I want miles per hour. So I need to do one more conversion. I need to say that I'm going to cancel out feet, and I'm turning it into miles, and I know this conversion. Hopefully we remember this. If not, remember it now. 5,280 feet in 1 mile, which means I can now cancel out feet, and what do you know? I'm left with hours, miles, or I should say miles, hours. Okay? I'm ready to get my answer. So now, what I do, I come over to my calculator, turn on. I would strongly encourage you guys to use the alpha y equals menu. All right, get a fraction bar. This bar is the bar going right down the middle. Now put everything you see in the numerators up on top in the numerator here. So 180, 60, 2 pi, and 2. All right, you see how I just multiplied all that together? And then put everything in the bottom. Now you don't have to put the ones, right? So 5,280. When I hit enter, I get 25.7. All right, so approximately 25.7, and then this was in miles per hour, or miles over hours, however you want to put it. But that is a good first example of a unit conversion problem. All right? Okay, let's keep going. There's about 4 more. We'll see if we get to them all. I might skip one just to save you a little bit of trouble. All right? I definitely don't want to skip this next one. This next one's a good one. I don't want to necessarily say it's confusing, but it shows you that we don't always have to be in units of length. All right? So if we take a look at this, we have a saw with a circular cutting blade, diameter of 10 inches, okay? Diameter of 10 inches. So let's draw that right now. And I'm not going to draw all of them, but we know if a saw, there's all those teeth, right? That's what a saw is. Teeth. Okay. Do we ever really want diameter? No, that's not really part of anything that we usually do with these formulas. So I'm just going to draw a radius of 5 inches. All right. Hopefully you guys are good with that. Let's see what else we have here. We know that it's spinning at 3,000 revolutions per minute. We also know that there are 11 teeth per inch. Interesting. Okay. Interesting. And then, so if you think about this, how many teeth cross the cutting surface each second? That means that we're looking to get teeth per second. All right, and what did we start with? We started with revs per minute. Okay, so this is just another unit conversion. I know it's goofy, it's not a unit of length, but we can relate teeth into length. Okay, so this is still basically a length problem with one extra step at the end. All right, let's see how this works. So we draw our bar to start our table. Oh my gosh, I'm struggling. And we know we started with 3,000 revs per minute, per 1 minute, okay? Up to you, but again, I strongly encourage you to just take care of time right away. We know that we're trying to go from minutes into seconds, so I put minutes on top because I need to cancel, which means seconds are on the bottom, and we know this conversion, there are 60 seconds in 1 minute. Boom, boom, seconds are good. Let's take a look what else we can do. We can say, well, let's see. We know how to go from teeth to inch, so that means we need to get revolutions into inches. All right, and we can do that. We can do that. We know that we're going to talk about 1 revolution, right? Because we're trying to cancel out revolutions. And we can say that in 1 revolution, there are 2 pi times 5 inches. And how do we know that? Because this is just circumference. In one revolution, it goes around one time, so we use 2 pi r. Alright, now revolutions are gone. Now we are in inches per second, but I don't want inches per second. I want teeth per second. So the last thing I do is I figure out how I'm going to convert inches to teeth. And when we read this, there are 11 per inch. So 11 teeth in 1 inch, which means I can now cancel out inches. I have teeth and seconds. That's exactly what I want. So we're ready to go to the calculator. And when we do that, let's see here, alpha y equals, so 3,000, 2 pi 5 11. I think that's all good, right? 3,000, 2 pi 5 11, good. And when we go down the denominator, just 60. Enter. Okay. So we finish up by writing, that's a lot, geez, 17,278.8 teeth per second. Alright? Cool. I think that looks good. Yeah, that's good. Alright. Let's move on to the next one. Same type of idea. We have propellers. Hopefully you guys know, even though like there's only really like 3 propellers or whatever, when they start spinning really fast, you know it looks like a circle, right? So I'm going to draw a circle, and I know that the radius of the propellers are 1.3. Be very careful, this is meters. Okay. And let's see here. We have 140 RPM. We want angular speed, and they tell us we want radians per second, okay? So again, a lot of the times I'll write this just so I know where I'm trying to get to. I have revs per minute, and I'm trying to get rad per second. Again, why do I do this? Because it should help me start to make my table. It should help me kind of lead me down the right path in my table. Alright, so I'm going to create my first section, and I know that I'm starting at 140 revs per minute. As usual, I will get rid of time first, or not get rid of, I will change time first. I'm trying to go from minutes to seconds, so minutes to seconds. And of course, there are 60 seconds in 1 minute. I'm good with minutes now. Alright. Be real careful here, guys. Revolutions to radians. I'm going to go back to the first page actually for a second. We're trying to get into radians, so where is that? Oh, it's right here. Alright. 1 revolution is 2 pi radians. So I'm not even concerned with length right now. I don't need 2 pi r. I just need 2 pi. So, this one's actually even easier. Alright. I have 1 rev, and there are 2 pi radians in 1 revolution. Let's see here. We have our radians. Sorry, I didn't cancel out revolutions. We have seconds. Guys, we're done. It's funny here, right? We didn't even use the 1.3, so be very careful. Be on the lookout. I might, or we might, give you extra information that you don't need. Let's slide this up. Let's get to our calculator. Alpha y equals. Alright, we have 140 in the numerator. We have 1, I don't care about that. I have 2 pi. And then down in the denominator, I just have a 60. So we are good to hit enter. 14.66. Are we okay with that? 14.66 radians per second. And let me box that. Alright. Alright, this is getting a little long, so we are going to do the next problem, but it's probably going to be our last one, and maybe we'll do the last one in class as a warm-up, but this is definitely a good one. So let's take a look at this, and then we'll call it a day. Alright, so we have a bicycle, 10-inch radius wheels. 10-inch radius wheels, okay. 10 inches. Alright, we are traveling at a speed of 25 feet per second, and we're trying to go to revolutions per minute. Interesting. Okay. So this is actually just kind of like backwards from what we're usually doing, right? Usually we give you revs per minute and we go to linear speed or something like that. Now we're doing it backwards, which is fine. We can do this. So we're going from feet per second to revs per minute. All right. Let's set this up and see what's going on. All right. So we start with 25 feet per second, and we know we're trying to get into minutes. So of course, I will say that I need to convert seconds into minutes so I can cancel out seconds. And we know what? There are 60 seconds in 1 minute. All right. So now we have minutes in the denominator, which is great. Absolutely great. We need to be really careful here. We need to be very careful because we started in feet, but any revolution calculation we're going to have to do, like 2 pi r, is going to be in inches, right? Because I give you this 10 inches. So what do you think we're probably going to have to do here? Hopefully you just said, we're going to have to convert this feet into inches first. So be very careful that units line up. Be very careful that units line up. So I'll put another bar here, and I know that I'm not going to be able to do any calculations unless I get this feet into inches. So feet, inches, and there are 12 inches in 1 foot, but this is good because now feet are gone. Now the last thing that we have to recognize is that we can get inches to revolutions, right? I can do that. I can turn inches into revolutions because this is a length, and I know length is 2 pi r per 1 rev. Alright, so in 1 revolution, there are 2 pi times 10, because 10 is our radius, inches. And now I can cancel out inches, and I'm left with what I wanted, revolutions per minute. So we go to the calculator to finish this last problem up. Alpha y equals, put everything from the numerators. So 25 times 60 times 12. That should be good. Don't need the 1. Yep. And 2 pi 10. Enter. 286.48. Okay, so approximately 286.48 revolutions per minute. And we will call that a day. Okay? So, basically, guys, I strongly encourage you to go back, rewatch the video if you need to remember any of this stuff. These are things that you're going to have to kind of keep in mind and remember for quizzes and tests. Other thing, go back, rewatch the video, and hopefully start to feel more confident with this unit conversion method. All right? We will call it a day, and we will talk more in practice tomorrow. Have a good one. Peace.